peaks that were named after their colors. So here, white, you've got black and red and whatever you want. You can also see here the most common peak names. This is an example of the kind of first usages that we've had for maps. So originally they were made to record geographic data. This is a bit modern and artistic, so maybe it's not the most formally correct way of presenting some data, but at least it's a good example of what you can do with interactive maps. The second example that I want to show you is about beer. So it's Friday, obviously we're all going to go to SAT afterwards. And the same actually group that did the visualization that we showed last week about repetitiveness in pop music did this interesting visual about craft beer and to know basically what the microbrew capital of the US was. This is kind of a good example of what you should do if you want to build a data story or any kind of data-based project in general. So you start off basically by showing what your premise is, like what are you trying to show, what do you want to explain, what are you working with basically. So here he kind of explains like what his original hypothesis is. So maybe New York City you'd think is a really good place for brewers. You figure there's a lot of them and it's a really like interesting hub for craft beer. But then he kind of says like, well, actually through this analysis what we're going to see is that actually Santa Rosa in California is much better, is a higher ranking than New York, let's say, for craft beer. So this was kind of an initial explanation. He gives a bit of context as well, like why does he want to do this? Like why should you even care that he's working on this? So I find that's pretty interesting as well. And then he explains kind of the big picture. Like through this analysis, this is at a glance, what did we find out? So here's a ranking of basically the top brewers in the US. And obviously you're all asking like, well, what does a top brewer mean? Like we all have our favorite beers, we all kind of, enjoy different things. And this is what he says, like add a caveat to your data. Like anytime you're gonna present something, you're making a choice. The data doesn't speak for itself. Like you're choosing something when you want to represent this data. And he actually makes it precise here and says like, he's just a guy trying to make a ranking. So what he does is actually lets people influence the way that the ranking is built. So here you have basically two axes on which you can work, so quality and quantity. Obviously these are subjective, so he says, well, why don't you just adjust kind of the mix between quality and quantity? And you can see how the ranking live evolves down here. So this is a good example again of the guy knows that he has some bias when he's presenting this data to you and lets you kind of challenge him. Say like, okay, well maybe you're presenting this result and you say, Santa Rosa is great, but why are you saying that? Let's see if I can find the same result or see something different with a different statistic, let's say. So that's, I think, is a really good thing that you should keep in mind for any data project. Then what he does is he adds a bit more information. So more context is always great because it gives you some background information, let's say. So here he's talking about, beer hype. Obviously, we're surrounded by IPAs and all kinds of different ales around us. And then he gives another specification. So yeah, great. That's awesome to say that there are a lot of breweries in a place, but yeah, maybe bigger places have more breweries. That seems like a fair assumption. So let's scale it and see how many, how we can scale that information depending on the size. So here he actually shows that Vermont, compared to its size, has much more brewers than the rest of the other states that you could have seen here. So this is kind of a full visualization. Again, what you should take out of this is to try to be as objective as possible, and even when you are, be honest about it. Like, people make choices, and if you can let people like challenge those choices, your visualization will be more robust, and they'll have better tendency to believe you. So that's really important. So we've seen some examples of some good stuff. We're going to see a lot more maps because this is the theme basically of Homework 3. If you've seen it, it's published on GitHub. You can check it out and we'll talk a little bit more about it later on. So this is funny map from XKCD. A lot of you probably already know it, which basically says like, yeah, maps can say anything you want. Like just, you can plot whatever you want as long as you make fun of Florida, it's fine. So this is, again, one of these historical examples of how we used maps. Like I said, originally we started kind of with geography. So that was a really important thing that we needed to map out our relationship in space to other people, other places. And then we realized, okay, we've got a good grasp kind of on like how the world works and how we interact with people around us. So we can try to overlay information because people understand. Like if you would show a map of the US to somebody in the 1700s, chances are they don't really recognize it. They don't know what's going on. Like they have no relationship with people like in California if they're from New York. But here you kind of go with the assumption that you know what the US is, you know what it looks like, and we can add some more information on it, meaning that this information actually has some geographic meaning. So here these are votes. This is a map from 1880, and it basically shows the US election at that time. And people are expected to understand that this represents a map of votes. So here are some good practices as well. Like we've got a label, and it's pretty easy to see that Republicans won, right? Does everybody agree? But no, actually not. At the time, Republicans had color blue, and the Democrats were red. So that's kind of like surprising, not really what you expected. What you should remember from this is basically that colors are not always what you mean, don't always mean what you think they mean. For example, in different cultures, colors can mean different things, and they're not universal. Like some color that you'll use at some point in time will not always carry the same meaning. Actually, in the US, just to come back to this idea, this is just to show, so this is the 1976 election here, and funny story, this map was built out of plastic and wood, and so when they turned on the lamps, it started melting the map, and so they had to bring in like a bunch of fans while they were live on TV, and it was kind of the first iteration of these online color maps, because it was one of the first elections that was on color TV. And in this case, basically the colors used were yellow and blue. And that's kind of weird, but remember in 1976, still the Cold War, so yeah, red for Republican, no thanks. So yeah, these are some of the colors, and you see the standard for blue-red kind of came in late 80s, early 90s. So yeah, that's something that you really should keep in mind as well. Like, it's not always universal what you think the color is, so always explain what you're trying to show with the color. Some other good practices that this old map uses and that you should still actually try to use today. So maps aren't the perfect solution to everything. Like if you have a lot of multivariate data, for example, like you shouldn't hesitate to use other visualization forms. So here a bar plot. Another interesting thing, he starts his bar plot at 0, which is good practice. You've probably seen a lot of crazy bar plots that start at random values. That's like a horrible thing to do because it just gives no sense of scale. So okay, like let's play data scientist for a minute. We need to show the election results for this year. What do we do? Like we're working for a TV station if that still exists, or we're a data scientist for a website or something. First, simple idea. All right, yeah, let's plot a map of the US and then say red for Republicans, because apparently everybody knows that now, and blue for Democrats. All right, is that reasonable? Like, sure, maybe, but this maybe isn't sufficient. Like, we don't know, for example, like how many electoral college votes, because that's how it works in the US, like each state represents. We also don't know how many people. Let's say our boss says, I don't really care about the result, I want to know how people voted. All right, sure. Let's try to scale the data by the people, because that makes more sense. We want to understand how people voted. Now this already gives a little bit of a different map. You can see a lot of the coasts have a lot of people, and they voted highly for Hillary Clinton, whereas the Midwest basically doesn't really exist, even though they counted in the election. Okay, that's a little bit better. And this, by the way, is called a Cartogram. There's actually a lab at EPFL that does really cool ones that you can see in a lot of French and Swiss newspapers called Koros, made by Jacques Lévy. And he actually is retiring soon. If you want to go see his lecture, it's really awesome. Yeah, so states, maybe not the best scale for representing people. I mean, obviously, there are like cities, big cities within states, and a lot of empty land or countryside, and they won't have the same political views. So what you can do is try to chop up your data into smaller intervals. So here, for example, we've got counties. Could be a bit of a better representation because, yeah, we can see cities at their scale. But again, like we're trying to model people. Like not everybody in the state voted the same way. So let's try to make more of, let's say, a linear scale. In this sense, we've got red would be completely for Trump, and blue would be completely for Clinton, and in between, purple. This is a linear color scale. You can choose a lot of different other color schemes. Bob probably talked about this a bit yesterday. it is important to think about the way that your colors transition and what they mean, like we've seen before. This also is important because in the case of voting, for example, we've got a linear relationship, right? Like it goes from 0 to 100, and yeah, that's basically it. But some other of the data that you're going to have to plot has nonlinear relationships, so you can't always have a linear scale. You can have a lot of people in like a first bin and then a long tail. So you want to find a way to kind of equally separate all these colors and categories when you plot it on a map. All right, so we've got a little bit of a better image of how the US voted. But again, we're talking about people. We're not talking about everybody doing the same thing, or kind of, this doesn't really represent how people voted in the US. Again, scale it by the meaningful variable here. And in this case, all of a sudden, we've got a completely different map than what we started off with. And we can show something very, very different. The weight of the cities is massive, and they're really highly for Hillary Clinton, let's say. And where Trump won his votes is basically in like lower income, smaller places all across the US. So through all of these maps, we've shown different stories, different ideas with the same kind of data. We need to really, again, be critical of what we're showing, how we're showing it, and why we're showing it. There's another variable we didn't take into account. I told you that we're showing how people voted, but we didn't talk about people who didn't vote. And that's almost half of the people in the US at the last election. This is how the map changes when you take that into account. I mean, that's kind of mind-blowing, right? I mean, if I showed you the map before, you'd accept my results and say like, oh, great, wow, like that's an interesting way of showing how people voted, but actually you're not showing people's behavior. So this is a perfect example of showing what you want to show and not like taking the whole picture into account. That's really important when you're seeing a visualization as well. Like, be really critical of what the person is showing you. Question their motives. And also when you're doing it, think of people doing the same thing to your visualization and try to make it basically clear what you're doing and why you're doing it again. So the other way to do it, data stories, we've seen some of those before. The New York Times is really good at this. We're going to just show a quick example of this because it brings together a lot of things we talked about up until now. So start with a simple map. This is kind of justified because we're trying to show electoral college votes. Color scale, kind of explained here. We can add additional information. This is a huge advantage of interactivity that we have nowadays, where we can add the number of votes, we can add the percentages, we can give this little level of detail and let people kind of choose the detail that they want to check. And again, maybe you want to see counties. This is the more defined or refined view that we wanted to see earlier. Maybe we want to see another metric. Differential metrics are always hard to show. So this is one choice. They made bubbles, the size of the lead, let's say. Justified, not, I don't know. Like, look at it with a critical eye. Like, this is not the only way to do it. This is maybe not the best way to do it. This is how they chose to do it. And this is another, like, interesting, let's say, way to show a differential variable. Arrows, like, okay, sure. Is that clear to you guys? I mean, I don't know. I kind of see a trend, but in a sense, like, does that really show me what happened? I'm not really sure. And again, we've seen this idea of showing more data on the side. And the last aspect of interactivity, you can zoom in. So if you really want to see precisely how it goes on, so we were talking about cities versus countryside. This is really clear in this kind of example by using just one map. And that's what interactivity can actually bring you, is to overlay different dimensions, different stories within a single map. So this is kind of the takeaway message. Representation implies bias. Every time you're going to represent data, it's not like, it won't be universal. Your data doesn't speak for itself. You make a choice, you interpret it, and you choose the metrics you use to interpret that data. So that's something that you really need to take into account, again, when you're doing a visualization or when you're looking at one. Be critical. These biases can come from statistics, so sampling errors, maybe, I don't know, you didn't choose the right sample, so you were looking at the right scale. Measurement errors, you don't have enough data and you just decided to interpret it a certain way. Maybe that interpretation is wrong. Like, why did you choose to use the mean and not 0, or just show that the data wasn't there? You can have biased estimators, so you're leading people in a certain direction, like we did before when we only showed people who voted and not people who didn't. That's a choice that I made when I made the map. You can also have visual biases, so like we said, colors. Red is associated with a lot of times, passion and maybe like danger. Some other colors like green would be more positive. These are things that you can bring people to think about the data. When they see a map that's all green, they're like, oh, that's great. And then you actually look and it's like the level of unemployment is really high when it's green. And you're like, oh, okay, well, that's not really what I wanted to show. Scale, again, we've talked about this before, like how big you're going to make your dots. Like if you're representing population, do you use like 1 pixel dots that are unreadable? Or do you try to scale it in some way? Shape, same thing. Design tells us that aggressive shapes give aggressive visualizations. And softer, like maybe squares or maybe circles, would be a little more soft on the eye and give a different representation, different feeling for the data you're seeing. So yeah, what do we do about that? Like there are a lot of problems. I talked about a lot of problems, and you're going to have to go through a lot of them during the homework. So like, yeah, what do we do? The first thing, and I mentioned this already a bit, is to be open and to be fair. That's, I think, really important. Be honest with the people you're working for or you're showing things to. And that we saw in the beer visualization, like the guy really says like, okay, I'm just some dude who's making a visualization. Judge me, have fun with it, and do what you want. But I'm honest with the way that I built this map, and you can criticize me or change the way that you view my data through that. Justify your choices, say why you did it. And there are also a few systematic methods that maybe we won't go into too much detail for. One of them I can mention, you can see, you'll check it out there, it's in the resources, is surprise. So basically the idea is just to show, instead of maybe the data or a scaled version of the data, is to show how much variation the data has compared to the prior that I was expecting. So that's why they call it surprises, like how surprising is this data that I'm seeing. You can also assess uncertainty, so you need to kind of explain, like for example on a bar plot you put error bars, kind of the same thing. Explain like how certain you are of the data you're showing. You can also talk about Demarcate Equation, which basically just tells you how the variance changes when you split your group into different subgroups. And basically the relationship is 1 over square root of the number of people in that group. So that just basically means that, like, if you have, let's say, a group of 100 people, and you divide it into 10 groups, the variance of those groups will be 1 over square root of 10 of the variance before. So you can, again, check that out a bit later. Yeah, okay, so now we have kind of the idea of how we should go about doing these maps, but we still need the tools. Bob mentioned a few of them yesterday. There are plenty of them out there. Like literally there are hundreds of different frameworks. They're all more or less valid. So what should you look for in these frameworks? So personally, what I look for, documentation. Is it clear what you can do with this library or framework or whatever? The second thing is expressivity, like how easy is it to do what you want to do with it? The other one is maintainability, like if you find some old library from 1997 and nobody's changed anything since then, probably not a great idea to use it. And then there's versatility, like how easily can you bend this framework to do what you want it to do? Not just, I don't know, some particular statistical framework that nobody uses apart from 3 researchers, I don't know where. The one that we're going to use is Folium. And basically, this is a Python port of leaflet.js, which is the same thing, a map visualization framework in JavaScript, which is really practical if you're doing web projects. Highly recommend it. As well as another one, d3.js that you see here. By the way, this was built by Mike Bostock, which you saw in the New York Times visualization. He's basically the one who made the New York Times the gold standard for visualization in journalism. And he built that library, and it's extremely well done. Highly recommend checking it out. So Folium, yeah, Python port. That means you can use it in your notebooks, which is awesome. 1 line, and you've got a map. Like, how cool is that? It's really amazing. The basic building blocks for these kind of modern maps that we have on our computers, basically 2 big components. The first one are overlays. They're basically shown as JSON files, so it's just a big dictionary of shapes. So this can be used to draw like boundaries, borders, arbitrary shapes that you want to add onto a map. And the map in and of itself is made with tiles. So basically you chop up your map into a bunch of different images at different scales, and then you put them on your map, and then the overlay comes on top of that, and you can show whatever you want. The interesting part about the overlays Since it's a dictionary, you can add whatever keys you want, and you can match the keys between the overlays and your data. As we'll see in Folium, it makes it really easy to plot data from other data that you have, maybe from a pandas data frame or something. So that was kind of the presentation. Now let's actually try to make some stuff. We're going to try to make it work, because obviously, when you're presenting, something is bound to go wrong. As you probably have seen, maybe, I don't know if you've downloaded it yet, it's on the GitHub repo. You can check out the notebook. If you want to follow along, we're going to go through it. It's just a quick introduction to Folium, so we're not going to go through the whole API. You can check out their documentation, which is more or less well done. You should start by installing it. Be wary for those who use pip to install it. Make sure you're using the right pip, because otherwise you won't have access to it in your notebook. So, all right, let's go. What are we going to try to do here? Start off by importing standard stuff like OS, pandas, whatever, JSON to treat whatever JSON files we need, and we're going to import Folium. I recommend using Folium 0.5.0, the latest version. Last year we used 0.2.1, I think, and yeah, some things have changed, but it's more or less the same. I just recommend having the same version as everyone, so if you have an issue, somebody can help you on Mattermost, or you can ask us. So the basics. I showed you a little bit of an example in the slides. Basically, the really first simple step is to define coordinates. So this is really classic, geography software stuff. Latitude, longitude. So let's start with Lausanne, for example, and build a map. Boom, you've got a map already. Like, I find that really awesome. So the maps load really nicely on your notebooks while you're in the environment, but then when you're going to push them to GitHub, you're not going to see them. That's normal, like, don't panic. We'll provide a little explanation of how to export your maps to HTML, so you can link to those directly and they'll open in the browser. Or you can also use an online notebook viewer. There are lots of them out there. Just you can copy paste the link to GitHub and it'll automatically render everything. So that's really cool. Don't forget to link it though, because we're not going to guess. So you can change a lot of things in these maps. I mentioned that there are overlays and there are tiles. So Folium supports all the tiles that Leaflet supports. So this, for example, is called the stem and toner. So there are a lot of different designers that worked on a lot of different tiles. This is one that's, it's, I guess, interesting. I'm not sure it's the best way to visualize the data for now, but yeah, it's cool. You can play around with them. There are some that look like paintings. It's kind of fun to change it around. And some of them actually really look good. Don't forget that some tiles are specific to some applications, so maybe some of them you don't want to use depending on what you're trying to do with this map. The second cool thing with Folium is that it's really easy to make your maps interactive. So the first way to do that is through markers. Let's define, again, a simple location, latitude, longitude, for EPFL, for example, and we can just add that to the map and show it. Now we've got a pointer here. As you can see, I can click on it, and I've got a little overlay. That's pretty cool. So we saw that a few times in other maps to show extra information. If you want to show, I don't know, the population in the city, you don't want to do like a huge scaled circle, add a pop-up, and you can add that additional information. You can format it however you want. It's pretty simple. All you have to do is create the marker here, give it the location, and there are a few little variables you can set. So for example, the pop-up is the text, and then you add it to the map. The other part that I mentioned, overlays. So this, like I said, is how we're going to draw boundaries, borders, and all kinds of different shapes. In this case, in the homework, you're going to have to draw boundaries of Europe and of Switzerland. So this is what you're going to use. So you're going to use, like I said, a topo.json file or a geo.json file. They're pretty much equivalent. Here I've provided one that's for the US. And basically, it's pretty simple. Give it the path to the JSON file. You can load it as basic JSON. It doesn't even have to be created with like the Folium constructor. Let's create a blank map. Again, I chose a different tiling. Personally, I kind of like this one, but it's up to you to choose which one you want. You can see here I set the zoom start. That's a pretty good feature as well. So if you're showing Switzerland, you maybe don't want to zoom into Lausanne, or you don't either want to like show the whole world, because yeah, we're important, but you know we don't take up a lot of space. Yeah, so we've got a blank map, and again, pretty simple. Just create your little object, and then add to it, and all of a sudden you've got all the borders of the different states overlaid onto your map, and that literally took like 4 lines of code, and you've got a cool interactive visualization of the states in the U.S. You can scroll through it, zoom it, you know, it's pretty clear. I mean, there you go. All right. So those are kind of the basics, really simple fundamentals of what you need for Folium. Honestly, I don't think you're going to need that much more, but just for the sake of an example, let's try to do something with these maps. We've talked a lot about the US election, and we're probably all tired of it, but let's do it, you know, one more time. I provided some data as well. So this is the US election 2016 binary. I call it binary just because it only says who won, so if Trump won or if Clinton won. This is standard, loaded into a data frame. Just show it, by the way. That's a useful function. Apparently not a lot of people have heard of it before, if I see the homeworks, but you can show just a part of the data frame. You don't need to print the entire data frame every time you show it. You can also use sample or give a number to head to show a certain number of the data frames. It makes it easier for everyone to get an idea of what's going on. All right, Folium allows you to define some custom colors. Like I said, we've got the overlay with the different states, and what we want to do is basically color each state depending on if Clinton won or if Trump won. So to do that, it's pretty simple. Like, this is kind of hacky. You can probably find a better way to extract the values, but whatever. If it's a Clinton win, then return this RGB string. So it's like a hex value that represents the RGB values. It's pretty standard. I don't know if you've all seen that before, but it's pretty simple. And then just pass that to your map. So create another map. Pass it the GeoJSON data like we did before. So that'll give it basically all the different states and everything. And you can provide this argument. So this is the style function that we just defined. The lambda is just an anonymous function, like we don't need to get into that detail, but basically it just iterates over all the values that I gave it in the CSV and uses and calls basically just my function with that feature or whatever. Like for example, for each state, it'll go and check you know, what the value is in that CSV. I can add some more configuration, so maybe some colors for the lines, change the weights, dash the lines, because yeah, why not? And there you go. Wow, cool. A map of the US elections. Pretty standard. I mean, yeah, we added some alpha so that we can see underneath, but maybe you don't want that. In the maps that I showed before, it was just like hard blue and hard red. Here you can kind of see the cities underneath. I kind of think it's cool because you get a better sense of geography, what's going on. Again, still interactive. You can go through it. It's fun, it's cool, it's awesome. So this, what we just saw is what's called a Triplet Map. It's a really common data visualization technique, especially when you're using maps. So this is basically, the Wikipedia definition, but the basic idea is just to overlay information on the geographic space, basically. This is what you're going to use in the homeworks. So we're going to give another example of what a Triplet Map looks like, just so you get a better idea of how Folium works and how you're going to be able to use this to create your visualizations. So same thing as before, don't need to show the whole data frame. In this case, we've got just the percentages for the winner. And yeah, obviously everybody knows Trump won bigly because he's, yeah, all right, I'm gonna stop there. Yeah, do the same thing again. This time, we don't need to specify our custom color function because Folium provides a way to define the linear color scale that I was mentioning earlier. You just pass the data, and it will automatically basically determine what are the lower colors, the higher colors, create a scale in between, and then just map basically the keys. Like I was mentioning, the JSON file is just a dictionary. So it'll have, like, for example, Arizona, and then it'll give all the points that it needs to draw to give the boundary of Arizona. And if you use the same kind of keying method in your data here, for example, here I've got, yeah, Arizona's here. AZ, and I know that in my GeoJSON file it's written the same way. I can just basically say, okay, take my data, take the column state and percentage, and match that to the JSON file that I gave you. And automatically it takes care of it, which again is pretty cool. The fill color here, this means blue and purple. There are a lot of different color schemes you can define. Most of them that are supported are given by Color Brewer, I think. You can go check them out. I provided a link to that. There are plenty of them. And again, think about how does it influence the way you look at this data? Like, I agree, this is not the best way to show that Trump won or the scale at which Trump won. So try to think of how you guys would do it. Like, what is your favorite color scheme? Would you go for a green to red or blue to red or whatever? Just try to think about it, play around with it, and see how that changes your perception of the result, like what you're seeing here. And now to the better part, saving your plots. So I mentioned that they don't render in the GitHub classic environment, but what you can do is save them to HTML, and that's literally takes just one line. And now I've got the maps that are rendered to HTML, and you got them in a full page here. You can go through them, scroll through them. Your interactions will still work. It's really simple to implement. Now the cool thing with this is that these are HTML files, so you can include them basically wherever you need them. I know that a lot of classes don't really provide the full picture. Like, we'll often ask you to make little visualizations and it'll be self-contained within the topic of the class, but we're trying to show something different with data, and we're going to try to explain like how can you actually make a data story. Like if you guys have a project, like what are you actually going to use to build this? So you can use the notebooks right away, because like you'll see that Folium's documentation, for example, is completely just a notebook. So it's a great way to show interactive visualizations. You've got a bunch of data, you can format your text. It looks really good. But if you want to do, for example, a web project, GitHub is awesome for that. They provide basically GitHub Pages. Maybe a lot of you have already used them before, but for those who haven't, basically they offer free hosting for your personal pages, for your project pages, your blogs, whatever you want to host. You have free themes, so it literally takes 2 clicks to configure. They've got Jekyll support for those notes. It's a blogging platform, that'll just take Markdown, so the basic stuff that you're using in your notebook, and it'll render it for you with the theme that you chose, or your own CSS or whatever you want. You've got version control, obviously, because it's just a GitHub repository, so you can commit, like collaborate, push, do whatever you would regularly do on a GitHub repo, and that's directly on GitHub for free. All of you, I think, have student accounts. If you don't, it's a great thing to sign up for. So just if like some of you want to go through this, it's really simple. Just go to GitHub, create a new repository. You've done that before, obviously, if you're doing this class because you needed it for the homeworks. You just need to go and configure it. So in the settings, basically you have this part that's called GitHub Pages. That's right there. And you just go through basically the settings. So you choose in the menu there, or maybe I can show you later. You can choose either the project page or just for a personal page. So the whole repo will be something, or just a branch of your repo will be the page. And you can choose a theme. Then you add your content, so just some simple Markdown again. It's really standard stuff that you've been doing already for a couple months now. And the cool thing is, like, for example, let's take the map that we designed during the little introduction here to Folium, saved it to HTML, we committed it onto our repository, and with this line, all of a sudden we've got our visualization that's included inside of the Markdown. So here is just a standard README, but maybe you're writing a blog article about, beer consumption at EPFL, and you made a cool map with Folium. You just need this one line to include it to your website, commit it, and it's on your website. This is what it looks like. For example, I did a little example yesterday. It's a standard theme. It literally took 4 clicks, and including the HTML. So if you guys want to play around with that, it'll be useful for the project. And if you don't use it for the project, don't hesitate to use it for your own personal fun or just to experiment. It's really great, it's free, and basically no strings attached. So that's pretty much it for Folium. Maybe we can go through just quickly the homework so you guys have a better idea, and then in the second hour we'll have basically office hours, so you guys can ask questions maybe about the grades that you had on the first homeworks, if you've had issues, or if you want to know more about the last homework. So the homework that you'll be doing is clearly related to everything that I've been talking about up until now. Interactive visualization using maps. So a few little introductions that we're giving here. You can read those. Basically, the idea behind this is to have you work on a lot of the caveats that I've mentioned during this session. So how representation can imply bias when you're showing something. Unemployment rates are a good example of that because there's a lot of choices that you're making. So for example, unemployment sounds like a very basic metric that everybody kind of relates to and knows what it's about, but when you think about it, what is really unemployment? Like some offices will provide unemployment numbers for just people who lost their job, or some others will count people who are in training to find a new job, or some other people will not count long-term unemployment or stay-at-home parents. These are a lot of different things that seem kind of subtle at first and kind of useless. Yeah, who cares? Okay, it's unemployment numbers. Like, why are you making this whole fuss? But it actually matters because people use these metrics to make decisions, whether they're political decisions, economic arguments, whatever you can think of. You actually are using these metrics to define and make policy. And the second thing you're going to need to check out is the colors. So how do you actually represent this information? Once you're clear on what you're showing, how are you going to show it? To do this,